Limits and improvements of rubrics from a complexity education perspective. Complexity education views learning as a non-linear, adaptive, and context-dependent process. Traditional rubrics have strengths in clarity and fairness but can conflict with this perspective. From a complexity lens, the limitations are as follows. First, there is a static bias. Fixed-level descriptors fail to capture non-linear leaps, regressions, and transitions in real learning, treating micro-strategy shifts or emergent solutions as out of rubric. Second, the risk of averaging and homogenization. Individual pathways and strategic diversity are reduced, pushing convergence toward a single right answer, and innovative approaches are underrated if they are not encoded in rubric language. Third, contextual erasure occurs. Situational factors such as task difficulty, collaboration structures, and resource availability are not reflected in scores. The same action can mean different things depending on the environment, yet rubrics struggle to distinguish this. Fourth, lack of process visibility. Process data, intermediate attempts, fail-fix cycles, strategy shifts, are lost, and outcome-centric assessment misses learning mechanisms. Fifth, separation of assessment and learning. When a rubric functions only as a post hoc judgment tool, the feedback experiment improvement cycle is broken. Sixth, the paradox of observability. The more we emphasize observable criteria, the harder it becomes to assess invisible cognitive regulation and metacognition. Seventh, neglect of multi-scale interactions, effects across scales, individual, group, tools, time. For example, team dynamics, tool constraints, are not incorporated. Corresponding improvements are as follows. First, adopt adaptive rubrics, shift levels toward range and pattern-based descriptors, explicitly indicating directionality of change. For example, attempts a strategy shift from A to B and reconstructs the rationale and include milestones and transition indicators. Strategy switching, speed of feedback incorporation, instead of fixed stages. Second, use context annotations, mandate recording of environmental variables, task complexity, resources, team composition, constraints, and attach context tags, for example, #tight time constraints, #tool limitations, alongside scores to enhance interpretability. Third, collect process-centered evidence, in addition to products, formally accept version history, decision logs, and traces of feedback uptake, and embed at least 2 mid-course check-ins into the rubric. Fourth, add a metacognition/strategy dimension, include self-regulation items, goal setting, monitoring, strategy switching, evidence re-evaluation, as a separate axis, and permit think-alouds, reflective journals, and design memos as official evidence to compensate for unobservable aspects. Fifth, apply dynamic weighting and portfolio assessment, shift weights by learning stage, raise weights on exploration/experimentation early, integration/refinement later, and assess via time series portfolios rather than single tasks to capture nonlinear growth. Sixth, include an emergent slot, at the end of the rubric. Add an open item that positively credits innovative attempts and creative strategies outside the rubric, while requiring concrete evidence to prevent arbitrariness. Seventh, co-design shared norms, co-create criteria and exemplars with learners to align with practice language, and perform lightweight renegotiation and fine-tuning each sprint as tasks evolve. Eighth, embed feedback loops. Design the rubric as a feedback and next actions proposal rather than merely a scorecard, appending recommended next steps to each level descriptor to prompt action. Ninth, use multi-level assessment, explicitly separate cross-criteria across individual, team, and system levels, for example, individual metacognition, team coordination/division of labor, system/tool utilization. 10th, secure reliability through calibration, train assessors with anchor artifacts, and institutionalize inter-rater analysis and consensus meetings. To concretize, here are example adaptive descriptors as a snippet. For the criterion strategy shifting, The exploration level is attempts at least one strategy modification based on feedback or performance signals. The adaptation level is monitors changes in performance indicators and redesign strategy after re-evaluating evidence, and the integration level is mixes and switches multiple strategies as situations demand and records the rationale for transitions. For the criterion reconstruction of evidence, the exploration level applies a single piece of evidence with partial awareness of its limits. The adaptation level contrasts conflicting evidence and states selection criteria, and the integration level integrates heterogeneous evidence to improve explanatory power and manages falsifiability. An execution checklist is as follows. Before starting a task, conduct a co-authoring workshop to agree on criteria, define contextual variables, and agree on evidence types. During the task, run at least 2 mid-course check-ins, record transition indicators, and review weights. At wrap-up, review the emergent slot, conduct a portfolio-based overall evaluation, and propose next step actions. Rubrics offer clarity but can easily miss the nonlinearity, contextuality, and processual nature of complex and adaptive learning. To compensate, incorporate adaptive descriptors, context annotations, process evidence, a metacognitive axis, dynamic weights, an emergent slot, co-design, multi-level assessment, and calibration into rubric design. Regarding several terms used above, milestones are key checkpoints, verification points, that confirm significant progress in projects or learning. They help visualize progress, detect risks early, and provide grounds for decisions such as continuation, revision, or termination. Milestones have clear completion conditions, deliverables, functions, approval criteria, assigned deadlines and owners, and serve as gates to the next phase. Examples include completion of a core function prototype and completion of user testing in product development, and finalized problem definition, submission of an interim report, and completed data collection in education/research. Practical tips: define outcomes so done is unambiguous, leave evidence, documents, demos, data, upon achievement, and, when needed, redesign scope and schedule. A sprint is a short, time-boxed iteration, typically 1 to 2 weeks, focused on producing and reviewing target outcomes. Its purposes are rapid learning and value creation, early risk discovery, and prioritization. Core elements include a sprint goal specifying concrete value for the cycle, selecting just the backlog items to tackle now, time boxing for focused execution, daily check-ins to share progress and surface blockers, and review and retrospective to assess outputs and improve process. Typical outputs include a working prototype, user feedback, and a documented list of improvements. Tips: define goals in outcome terms. For example, complete user testing with 5 participants for feature A, slice scope small to raise completion likelihood, and include at least 1 improvement experiment per sprint. Cross-criteria are multiple sets of criteria used to assess the same target, performance, behavior, artifact, simultaneously from different dimensions, levels, perspectives, units. They mitigate single criterion bias and enable balanced appraisal of multi-layered quality across individual, team, and system levels. Features include multi-layered assessment, individual capability, team collaboration, organizational/system conditions, cross-validation among criteria to improve interpretive reliability, and contextualization by linking to situational variables such as resources, constraints, and difficulty. Practical tips: minimize redundancy across criteria, provide clear definitions with evidence examples, summarize results in a cross-matrix to compare strengths and weaknesses at a glance, and secure interpretive alignment through consensus meetings with adjustable weights. Anchor artifacts are representative exemplars used as reference points when interpreting evaluation criteria, such as rubrics. They are real outputs or records that show this level or higher by level. Their purposes are to raise inter-rater agreement and to make expected performance concrete for learners. Features include level representativeness, novice competent excellent exemplars, inclusion of context information, task conditions, resources, constraints, and annotations that justify why an exemplar fits a given level. Usage: run calibration sessions where assessors practice scoring with anchor artifacts to reach interpretive agreement, share them with learners for self/peer assessment, and keep them current by adding or replacing excellent or borderline cases as tasks evolve. Examples include, for writing tasks, a Level B exemplar with generally clear claim evidence links but weak rebuttal handling, annotated PDF, and, for programming tasks, a Level A exemplar with greater than or equal to 85% test coverage, consistent exception handling, and attached performance logs. Repository link. Tips include borderline cases to improve discrimination, anonymize for IP/privacy, and link annotations directly to rubric wording to enhance transferability. A snippet is a short excerpt that conveys a core function or idea in a document or code. Use cases include code examples and grammar/pattern explanation, sharing small reusable functions, and quoting key passages in writing or reports. Characteristics include brevity and self-containment so it can be understood or executed immediately with minimal context, and purpose orientation that clearly demonstrates a specific function or concept.